as some basic prep for the upcoming Hacktoberfest fund that I hope everybody here and even more than here will participate in. So let's go ahead and dive right in and learn a bit more about open source software and Git. We'll start with a brief introduction of myself. My name is Sandy. I'm currently a staff software engineer at P&G. I am here because I love to give presentations. That is really a lie. It's really my attempt at some humor to start this off. I actually hate to give presentations, but I know it's a skill I need to work on. So here I am trying to get better, and I think eventually I will love to give presentations. So don't be afraid to challenge yourself to do this as well. In terms of open source, I've worked on some open source projects over the past 6 to 7 years, and I've been using Git and GitHub during that same time span. If you ever need to contact me, please feel free to reach out. You can reach me on Slack, the Women Who Code Slack at Sandi, or you can send me an email, Sandi with an I at Women Who Code. I'm always happy to connect. Also, as we're moving through this presentation, please feel free to stop me and ask questions or get clarifications if you need them. If you're not comfortable stopping me, please feel free to drop a message in the chat. Sierra will be monitoring the chat. So we just want to make sure that everybody has the opportunity to ask questions and get those questions answered. I also want to make sure that everybody here understands, like, we are here to help everybody improve. So don't be afraid to ask your questions. Even if you feel like it's basic, I can almost guarantee you that somebody else has that very same question. So please get the most out of this that you possibly can. So ask all those questions. All right, moving on. Open source software. What the heck is that? I think we've all, everybody's heard that term. Is it a buzzword? I don't know. But really, when it comes down to it, what is open source software? When I was researching this talk, I came across this quote, and this is a quote from Linus Torvalds, and I apologize if I say his name wrong, because I probably did. But Linus is the creator of Git, and he's also a big proponent of open source, and sometimes referred to as one of the 5 fathers of open source. So I thought this quote was meaningful and kind of gave us a good starting point for the presentation. And he said, in open source, we feel strongly to really do something well, you have to get a lot of people involved. So he's saying, instead of keeping your group small, we really have to get a lot of people involved, and that's what makes open source the best thing it is. And I thought that was pretty interesting. So when it gets down to it, nuts and bolts, what is open source software? So open source software is software that anyone can examine, modify, and distribute. Basically what that means is the source code is publicly accessible. You can go out, you can get it, you can look at it, you can change it, you can do whatever you want with it. It's there for your use. It's released under a license that basically grants users the rights to use it, change it, distribute it for almost any purpose that they could want. An example of open source software is Ubuntu, which is an open source operating system. You can download Ubuntu, you can create as many copies as you want, you can give them to your friends, you can install it on an unlimited amount of computers. You can get the source code, you can modify it, you can create your own custom version. You can pretty much do whatever you want with it. The open source licenses allow you to do all of this, while a closed source license, to contrast that, would put a ton of restrictions on you and probably prohibit most of those things. So later on, when we create a new repo, we'll review the licensing a little bit just to kind of help understand that concept. So what are the benefits of open source? Why would we want to support open source or use open source software? Well, first and foremost, it has a lower cost because it's actually free. The code is all free. You can copy it, you can use it, you can change it, whatever you want to do with it. It's 100% free. It is also very flexible, so you can alter it to meet your needs. If you have a project in mind, you can go out and search for some code that does something similar. Then you can get a copy of that code and you can change it to do whatever you would like it to do. Open source is also very collaborative and transparent. You can, there's tons of open source communities out there that support open source software. Rather than having a single author or a single company supporting software, you don't get that. You get a general perspective on things rather than a single owner and a single company owning the software. That makes it a lot more collaborative. They welcome people into the group and they want you to contribute to it. It's also very transparent and reliable. It's transparent. Obviously, you can go out, you can see the code, you can see the history of the code, you can see all the changes that have been made, you can see the issues that exist against that code. You can pretty much figure out anything you want about that code. But open source also tends to be more reliable. It's more reliable because there is a community that supports the code. They have some standards. There's a lot of peer review that goes along with code changes, and it's often very well tested. So open source code is oftentimes more reliable than a closed source code is. So it's one thing to talk about open source, but I think it makes it really hit home when you think about what actually is an open source project. Well, these are the top 10 open source projects from last year. This year's list will be different probably because this year's all wonky too. But anyway, for these 10 projects, if you go out and you pull the slides down when you're done, all of these are clickable links. You can actually go out and look at the source code for any of these projects. You want to go see what the source code for Vue is? It's right out there on GitHub. You want to contribute to Bootstrap? Go out there and see what you can do. So I thought it was pretty cool that we've probably heard of most, if not all, of these open source projects. And maybe you didn't even realize they were open source. I often don't think about that thing myself. All right, so if open source code is collaborative and anybody and even everybody can contribute, how the heck is the code maintained? How do we keep it from turning into a giant mess because there are so many contributors? How do we manage that sort of thing? And the answer to that problem is version control systems. A version control system is a software tool that helps manage changes to source code over time. It also keeps track of every modification to the code in a special kind of database. Excuse me. It tracks every change made and it gives you greater control of those changes, and which allows you to recreate the code base at any point in time. It's actually pretty cool. And there are 3 general basic types of version control systems. The most simplest form is a local version control system, and it's basically like a database that keeps track of the files and the changes. So it will create little patch sets for the changes. And then if you want to recreate the code at a certain point of time, you can add up all those patch sets to recreate that file. It's very, very simple. It also can get pretty ugly if you get a lot of people in there and things get kind of crazy. So a step up from that would be a centralized version control system. And in a centralized version control system, there's a single repository that contains all the history of the code. And then each user gets their own working copy of the code, which is the latest snapshot. You can commit your changes in the repository, but others can only see your changes when they update their working copy. So you would get your snapshot down, make the changes, push it back up, and then others would have to go and get that latest snapshot and pull it down. An example of that is Subversion. I think there are still a lot of companies that use Subversion as well. And one step beyond that would be a distributed version control system. And distributed, the biggest difference between centralized and distributed is the number of repositories. In a distributed system, there are multiple repositories where each user has their own repository that contains all the history in addition to their own working copy. You still must commit your changes and push them up to make them visible in the central repository, but it's a little more manageable than a centralized repository. And the biggest example of a distributed version control system is Git. And today, that is exactly what we are going to focus on. We are going to talk about Git as our version control system. Git was created in 2005 by Linus Torvalds while he was developing Linux. Git is an open source software project that is used to manage open source software projects. I thought that was a pretty neat kind of fact as well. All right, so let's dive right in and start working. And I think what I'm going to do is I'm going to live code this, and you're welcome to follow along with me if you want. These slides will be available so you can circle back and follow through them later as well. And once again, if you have any questions, please feel free to ask them at any time. So the very first step anybody has to take is to download Git. If you don't already have it downloaded, you can come to these slides and you can click on this link. You can also just Google it, and it's very easy to find. So then once you have it downloaded, I'm going to switch into live coding mode here. Once you have it downloaded, there are a bunch of configuration variables you can set up. I personally don't set up many, but two that I think everybody absolutely has to set up are your username and your user email. So I have Git installed, so if I want to set up my configuration variables, I would just type git config -- global user dot name. I'll find my name. And clearly I typed it wrong because we're live coding. Get to see all my typing flaws. But Git does a very good job of telling you, hey, I don't know what that is, but look at all these options you can choose from. But when you type it right, it's all good. So that set up my username. The next thing that we're going to do is we are going to set up our user email.
Global's wrong again. Go back.
Thank you. See?
Yeah.
It's the nerves. They get you. All right, there we go. So I set up my username and my email address. You can verify this by typing git config -- list, spelled correctly. It's always a bonus. And you'll see my username is Sandi Ritter, and my email is set up to be that. You'll notice that I have this one extra line down here. It's an alias that you can set up. There's lots of aliases you can set up. I only have one, and I won't dive into it too much, but I type git status so often that I created a shortcut for it. I type it ridiculously often. That's okay. All right, so we have our configuration variable set up. So why did we do that? Well, we did that because those configuration variables are used to track who you are in the system. So Git now knows your username and it knows your user email address. It will use that identity to associate you with every commit that you make. Also, the -- global flag indicates to Git that you want to use this everywhere. So everywhere you want your username to be equal to that, and you want your email to be equal to that. At the end of the presentation, I'll have a resource document of other configuration variables that you can set up. All right, so next you'll go to, slide. Okay, next thing we are going to do is we are going to navigate to GitHub. Get out of my way. GitHub. Okay. Once you have Git downloaded, the next thing you need to do is create an account in GitHub. I'm going to quickly create a new account here just in case there's anybody who doesn't have an account so that they can follow the steps. So the first thing you have to do is choose a username. Feel free to be creative here. I can't pick that one because I already have that one. So let's see if I can, there we go. Sandi Ritter, Women Who Code is available. I am going to set up my email here as womenwhocode.com. Okay, and my predetermined password that I use for everything. So this is all you need to do. Click the button and you're signing up for a GitHub account. I need to say that. It's going to ask me to solve a puzzle because why not? I'll choose the Spiral Galaxy. I will join a free plan. And I'm going to skip all this setup just because we don't need to talk about that today. So now I should have a verification email in my email box over here. Let's see how fast Git is with this. Verify your email address. You click on the button and bam, your email was verified. You now, I'm going to skip all this for now. You now have your very own GitHub account. So those steps are very easy. However, I'm going to sign out of that and I'm going to go back to my real account. It helps if you click the sign in button. Oh, 5 credits already. There we go. All right. Oh, great. Now it wants me to two-factor off. It's just easier to go back to my main account. I apologize for this. I just wanted to be able to show people how to create, how easy it was to create an account in case they didn't have one. So now that you have an account, the next thing we're going to do is we're going to create our own repository in GitHub. All right, so tonight we're going to leverage a feature in GitHub called GitHub Pages. So when we're done here, if you follow these steps, you'll have your very own static website powered by Jekyll. And it's super, super easy to do. So when you're in your GitHub account, you want to find this that says repositories and you want to click new. So we are going to create a new repository. Now for the purposes of this example, we want our repository name to be the very same name as your username. So Sandi Ritter, spelled right. .github.io. That's what our repository name is going to be. We want our repository to be public. That means anybody can see it. We are going to add a README file, which will be blank for right now, but that's okay. We can circle back later and fix that. And we are going to choose a license. And these are the licenses I referred to earlier. I am going to choose an MIT license. And after we create this, we can go out and look at it and see what it looks like. So once that all is done, all we do is create the repository, let GitHub do its thing, and magically we now have a repository. In my account, I now have a repository, sandyritter.github.io. And actually, we can navigate to that. And great, GitHub Pages is temporarily down for maintenance. Well, isn't that a treat? Normally you would just see, it would put a little splash page up and you could see that. So hopefully that resolves in a little bit. But while I'm on this page, I want to real quick show you the license. I chose an MIT license. There's various licensings that you can choose, and I will have a resource at the end of this talk that kind of goes over them. But basically, if you read through this, it just tells you that you can pretty much do whatever you want with this code. Free of charge, you can get a copy of it, copy, modify, merge, publish, like all sorts of things. So you can dig into that later. All right, now let's go back here. And now that we have a repository, we want to clone our repository down locally on our machine. And the way we do that is we come to this big green code button and we click the arrow and it has the URL for our repository. And all we have to do is click this little link right here and it will copy it. And then I am going to hop back over to the command line. I personally only use the command line. It's really a personal preference. There are plenty of Git GUIs, graphic user interfaces that you can use that some people think are a lot easier than using the command line. A couple examples of those are SmartGit and Git Kraken. But for tonight, we're just gonna stick on the command line. So I wanna take that repository and I wanna clone it down locally. So what I like to do on my machine is I create a place where I store any repository that I would clone down. For me, I use this I created a folder called source, but everybody has their own personal preference, how that is. So right now I am in my source folder, and if I list out, you'll see I have several repositories cloned down here. But let's go ahead and we are going to clone the repository that we just made locally. And you do that by typing git clone, and then you can paste in the URL that you copied from GitHub, and you press enter. And bam, it's done. You now have cloned that repository down on your machine. But now I want to change directory into this repository so I can actually make code changes. So I do that by, here, let me show you, I listed out. Now I have a sandyritter.github.io repository. So let's change to that repository. All right, and there we are. So now we're in there. We are on the master branch. There is an empty README and a license file. In that, that's all we have right now. But let's go ahead and let's make an update to our repo. And we're going to start super basic. We're going to do it right here on the command line, just to get something out there. And to do that, we're going to type the word echo, followed by some text. We'll just say, I'm just going to say Women Who Code. And then the greater than sign followed by index.html. And what this command is going to do is it's going to echo this string into, so this means into a file called index.html. And now you'll see that we have a file called index.html. Now, like I said before, I'm a big proponent of git status. I'll actually type it out, but I do it all the time. But just to see, I just want to know what the state of my local repository is. So if I type git status right now, it tells me that I'm on my master branch. I have an untracked file, and that file is called index.html. It also gives me a hint, like, what's my next step? Use git add to track that file. That is absolutely what we are going to do. So we're going to type git add, and then we're going to do git status again just to see what it looks like now. So now Git tells me that I have a new file called index.html, and it is a change that I can commit. So you can see the difference between it being untracked and now it's being tracked, and Git knows that it's a new file. So now that we have a file and we've added it, the next thing we need to do is commit it to our local repository. And we do that by typing git commit -m for your message. And then you want to put a meaningful message here that maybe isn't too verbose, which I struggle with that sometimes, I'll admit. So we'll just call this our first commit. All right, great. So it says one file change, one file inserted. Also, if I do my favorite command, git status again, it tells you that I have nothing to commit. My working tree is clean, but my branch is ahead of master by one commit because I've committed something locally, but I haven't pushed it back up to our master branch yet. So let's do that. Let's push this sucker up. And you do that by typing git push, spelled right, push master up to our master branch. And it's successfully completed. So now we should be able to navigate back to our URL and see these words on the screen. Let's go see if GitHub Pages is gonna work for us now. Oh, yay, it did, hooray. So I now have my own static website that says Women Who Code. It's not much, but for 5 minutes worth of work, that's pretty cool. So let's stop for a minute. Go back to my slides. Show you all my slides. And let's dig in a little deeper to what we did. Let's take a step back and review how we moved along. And let's start by talking about cloning versus forking. So when we started, I cloned my local repository. There's also an option that you could do that's called forking. And basically the very starting point of any project is either cloning or forking a repo. And for me, This was probably one of the more difficult ideas to wrap my head around and to keep straight. I personally don't fork a lot, so I tend to forget like in what situations I would need to fork. So I'm going to try to describe it for you here, and we'll go through a little exercise that hopefully will make it a little bit more clear. But most commonly, forks are used to either propose changes to someone else's project or to use someone else's project as a starting point for your own idea. Opposed to that, if I clone a repo and make changes, it's a repo that I own and that I have contributor access to. Cloning creates a copy of the repo on my machine, but that copy that I have is still tied directly to the repo in Git, and I have access to make changes directly to that repo in Git. But if I fork a repository, it creates my own version of the repo in my GitHub account. I would then need to take that repository and clone it down locally so that I can make changes and then push those changes back up to my personal fork. Using that strategy, I don't need to be granted access to the source repository to make changes. My changes can still be pulled into the source repository by the project maintainer. All I have to do is create a pull request, just like you would normally. But this model tends to reduce the amount of friction for new contributors and is popular with open source projects because it allows people to work independently without a lot of upfront collaboration. To try to make this a little more clear, I'm going to show an example of this. So here is an open source repository for Dragula, and we are going to fork it real fast just to kind of help solidify that concept. So I'm not going to come down here and clone it. I'm going to come up here in the corner and I'm going to click on fork, and you'll see 431 people have already forked this repository. Let me sign it. There we go. So I'm going to click fork, and it's going to ask me, because I have more than one repository linked into my account, it's going to ask me where it should fork. If you were doing this on a brand new account, it would just automatically fork it right in. But I'm going to fork it to Sandi Ritter. So I click on that, and then GitHub does its thing. And what it's doing is it's creating an exact replica of the code that was in the main repository. And now you'll see that I have the ng2 Dragula code here, but it's under my account. And then if I wanted to make changes, I would now have to go through the cloning process as well, where I would come over here and I would click and I would copy and I would get cloned locally. So it basically makes a mirror image of that repository in your repository. And I know that may not be super clear, but I hope it's helpful in some way. So I just have a couple slides, just so you know if you're coming back where you need to click, and that if you have multiple repos tied there, you're going to have to select where you want it to go. But now that we've talked about cloning and forking, let's talk about some more basic Git terms. One of the most basic terms you'll hear over and over again is repo or repository. And basically that is just a project's folder. It's where all the code is housed. It contains all of the project files and all of the revision history. It can be public or private. As you saw when we set up our new repo, we got to select whether we wanted it to be public or private. And then branch. A branch in Git is it's like a copy or a parallel version of a repository. And generally it's used to change code in an encapsulated environment. So if I want to go out and update my code to do something, do gesture A, I would make a branch, make all of my changes in that encapsulated environment, and then get those changes back into the main repository. Checkout is a term you'll hear and use frequently. It just means switching between different versions of the code. It's generally used with branches. Generally, you'll check out one branch or check out another branch, but it can be used for other things too. And Git status, which we already saw, is one of my favorite commands. It just shows you the state of your working directory. So you can see what's going on. Do you have untracked files? Do you have staged files? Do you have unstaged files? It just always tells you exactly where you're at in the process of updating your working directory. And then committing is the process of making a revision to your repository. Every time you make a commit, Git creates a unique ID, which will be referred to as a SHA or a hash, that allows you to keep a record of those changes. Your username and your email address that you set up in your Git config will be tied to that SHA. And it's a very nice way of tracking every change that's been made to the repository. Pull request is another term you'll hear often. Sometimes you'll hear it referred to as a PR, just a little abbreviation of that. But a pull request is basically proposing changes to a repository, and it can be accepted or it can be rejected. Essentially, you are asking to have your changes pulled into the source repository. So you're going to take your branch, you'll create a pull request that you want to have made into that repository. A couple more useful terms. Add. So if you do git add, which you saw that earlier, it adds your changes to your working directory to your staging area. It just adds them. They're not actually recorded yet because the commit is what actually records them and associates a SHA with them. Push is a command you will use frequently, and that is how you send your committed changes up to your remote repository in GitHub. You push them up to the repo. These three are kind of related. Fetch. So if you do a git fetch, it retrieves the latest metadata info from the original, but it doesn't do any file transferring. It's just like a check. Check and see what has changed and let me know. A merge will actually take the changes and apply them from one branch into another. Now, what I tend to use more often is a pull. So when you execute git pull, it is a combination of two Git terms. So it fetches the content and then it updates them and merges them in to the repository. So it's a combination of a fetch followed by a merge. I've just always used pull instead of using these two separate terms, but it's good to understand the underlying basis to a pull, and you can also, it's equally acceptable to use them individually as well. So that was a lot of terms, a lot of stuff. I don't know about everyone else, but for me, the best way to really dive in and understand it is to practice. So let's do a quick exercise here. And we're going to follow this basic flow. You're going to create a branch, you'll alter your code, commit your changes, you'll push those changes to your repository, we'll go to GitHub, we'll look at those changes, we'll create a pull request, and then we'll also merge those changes back in. So let's go practice. And once again, I am going to live code this. Please feel free to interject or stop with anything you might have. So first I'm going to clear my screen. All right. So the first step to making any change to me is to create a new branch. So you can type git branch and it will show you all the branches that you currently have locally. Right now I have one and it's master. And it's harder to tell because I only have one, but it is a different color and it does have an asterisk by it because it's my active branch. So let's go ahead and create a new branch. And we can do that by typing git branch followed by whatever you want your branch name to be. We will call our branch add content. So I have created a branch. Now if I just do git branch again, we'll see that I have two branches, master and add content, but I'm still on master. So I want to switch to my add content branch. And I would do that by typing git checkout followed by the branch name. So now you'll see my branch name has changed here, but also if we just type git branch, the asterisk is next to the add content branch. Now, There is a shortcut. You don't have to do both of those individually. You can type git checkout -b, which will create a branch, and then you have to choose another animal. And that in one step creates your branch and checks it out. So you'll see automatically in that one step, I have changed.
Can you
Yes.
repeat what setup do you use to see the branch names?
Oh, how my editor is set up here?
Yes. What setup do you use to see the branch name, colors, etc. in your console?
Oh, I'm actually using, so my editor is set up to use, what am I using? Oh My Z Shell, I think is what I'm using. And within that, you can set, there's a ton of different configuration that you can set. So you can set up your colors, how your branches showed, your repository. I have stuff over here that we're ignoring for right now. I can dive into that a little bit deeper later if we have time, if that's okay. But that's based on how I have my shell set up right here, my terminal.
And Sandy, this is Jim. That was my question, and I didn't know if you had explained it or not, and I was just curious what it was. So yeah, if there's time, that's great, but if not,
Okay.
I think just knowing what it is, that's cool.
Okay, all right, cool, thanks. All right, now I'm gonna go back to, because I'm anal, and I want to be on the first branch that I created, which is add content. Okay, so now I'm on my add content branch. I've checked it out, and we are ready to make some changes. So here's where I would go to whatever my favorite editor is, whatever your favorite editor is. Tonight, I am going to use VS Code. So let me go open up VS Code. And let's see here, I'm on my GitHub IO branch. Here's the index.html file that's associated with my github.io branch. It just has those 3 words that we put in it earlier. I'm going to cheat in the interest of time. I have my test file sitting out here that I can copy and paste from. So I'm going to do is fancy up my index.html file, and I am going to add a photo because I want to. So I'm going to save this file in. So I'm going to go to my source directory, and this is, put it there. All right, so now I have, close that down, I have my index.html and my photo that I want to add to my repository. So I'm going to come back to my command line. I'm going to type my favorite command, git status, and it says, oh, look, you have a modified file. You've modified index.html, and you have an untracked file. You added this PNG file that was untracked, which I did both of those things. So we're going to follow the same steps. We created our branch, we checked it out, we made our code changes. Now we are going to commit them. All right. And see, I forgot a step right off the top. You have to add your files before you can commit them. And because I'm anal, I'm going to type git status again. And it will show me that I've modified my index.html, and I now have a new file that I'm going to add. Now I can commit them. It doesn't matter how long you've been using Git or GitHub, you're going to make mistakes. So just be sure to be patient with yourself. All right, so now I've committed. If I do a status, it says my working directory is clean, nothing to commit. So now I'm going to push this branch up to GitHub. So I'm going to do git push origin add content, which is my branch name. So I am pushing this branch up to my origin. And the changes are fairly small. So there we go. It's pushed it up to my account, Sandi Ritter, to this repository, a new branch called add content. So let's go back to GitHub now. And mods. All right. Okay. So we've done all that stuff. Let's request. And we're going to go to, let's refresh here because that was prior to. Yes, I know. So I'm going to my account, my repositories. This is the repository that we're working on tonight. And GitHub is fabulous in that once you push a change up, it gives you this nice bar that says, hey, you've pushed something up. Would you like to compare it and make a pull request? Well, yes, I would. So you click the green button, and this will bring you to a screen where you will open your pull request. When you open a pull request, in this block on the far right is where you'll choose the branch that you made your changes. So my branch is called Add Content, so I want to make sure that's selected. And then I'm going to merge into master. So this branch, arrow, meaning merge into master. So this is all set up just the way I want it for right now. But just be cautious as you get more branches. Sometimes you do have to make changes here. So it's just something to keep your eye on for the future. So that's set up correctly. You can add any title you want. I'm just going to keep it the way it is. You can scroll down. You see that I made one commit. I changed 2 files. It's going to show me what I changed. I added some more HTML and I added a PNG file. So that all looks great. I am going to create my pull request. All right, so now I have a pull request available. Oftentimes some repositories, you'll always have a lot of pull requests open. It just depends on the number of moving parts and the number of contributors. But you can always go click on this pull request icon up here and we'll show you all the pull requests. There's also a bunch of ways you can filter them, but because we only have one, we don't really need to filter them. So if I come to my pull request and I click on it, it brings me to the screen. And once again, generally you'll have somebody else probably review your pull request, so it won't be like you doing the very same thing, but it could be. But it's pretty much the same options that we saw before. It'll show you the number of commits. It'll show you how many files have changed. You can click on that so that you can make sure, yes, these are the changes that I want to merge in. You go back to conversation and you click on merge pull request and it will make you confirm your merge. Yes, I do definitely want to merge those in. Now, one thing I do want to call out is this block right here. Once your changes have been merged in, it's probably a good practice to delete your branches just to keep your repository nice and clean. You can also set your repository up that when you merge a pull request, it will automatically delete the branch. But for now, I'm going to click the button, and so I delete my branch because my code has been merged back into my master branch. So if I come out here and click on code, and I've got my master branch selected, you can see that 4 minutes ago, I added a file and I updated my index.html. And now, if we're lucky, we can refresh this and we will see the changes that we made. So it's really pretty easy. I encourage everybody to get in there, create your own, get out here and create your own static website. Like, this is a super cool thing. You can put whatever the heck you want out there. And you saw we did this in just a handful of minutes. So think what you can do if you have a couple hours to spare. It's a pretty cool thing. But anyhow, let's move back to the slides. All right, so why have we done all this? What was our point? Well, the goal of tonight was to try to get people more comfortable with open source and with Git and with GitHub so that they can contribute to Hacktoberfest. You might be asking yourself, what the heck is Hacktoberfest? Well, it's basically a celebration of open source software, and it occurs during October, and it encourages participation in the open source community. And they don't just want experienced people to participate, they want new people to participate too. So the gist of it is, during the month of October, so between the 1st and the 31st, you make 4 pull requests to any public repository on GitHub. And if they're accepted, you will get a super cool free t-shirt. One thing to call out is there are some rules around this. So there's like a 7-day review window for pull requests. So you have to create your 4 pull requests, and then you enter the review period. And then if they say your pull requests are good, then you get your free t-shirt. It's still pretty cool. So you definitely need to go to Hacktoberfest to register. When you get the slides, you can click on this link, or you can Google it. It'll take you right there. And it's super easy to register. And you might be thinking, well, how the heck am I going to find something to work on? Like, regardless of your skill level, whether you're a beginner or whether you're experienced, like, how do I go about finding issues to work on? Well, for purposes of this presentation, since we were focusing on maybe the beginner, the more basic skill, I have some links here that you can click on, and these will take you to repositories where pretty much their goal is to find issues that beginners can work on. So you can come out here, you can click on all these links, see what's out there. In addition, on these, you can also, GitHub has labels that you can search for. So I have 3 labels here where if you come out here and click on these links, it'll search and it'll bring up all the issues that it'll find. We'll do one real quick. So here's, if I searched in GitHub for a Hacktoberfest label, I get 103,000 issues. Some of them are open, some of them are closed. So you can click on what you want. I only want the open issues, and they're split by language too. If you say, well, I only want open issues for Python, and it'll filter it down to that number of issues. That makes it a little bit more manageable and easy. But there's a lot of options out here. So if you have time, please dig in and go out there and see what you can find to participate in. And most importantly, we want you to join the Hacktoberfest Fund. So be sure to sign up. Once again, here's another link. It'll take you to the Hacktoberfest site. If you want that free t-shirt, you have to sign up. If you just want to participate, you don't necessarily have to sign up, but heck, if you're going to participate, you might as well sign up and try to get that free t-shirt. Also, please join our Cincinnati Women Who Code Slack channel. We have a specific Slack channel for Hacktoberfest. Please go out and join it. And I encourage a lot of participation there. Feel free to share resources. Feel free to ask questions. Feel free to, if you even have questions about, oh my gosh, how do I set up my repository in Git? How do I set up Git locally? Like, please feel free to drop questions in there. Our goal really is to help everybody and to make this an enjoyable and fun experience and a good learning experience for everybody. And then most importantly, attend our next meeting on October 24th, where we will dive into Hacktoberfest and get our hands wet. And it will be tons of fun. As promised, here's a slide with some resources. I tried to sprinkle a little bit of stuff in here. There's some GitHub training if you're interested, some Git cheat sheets. This is a really awesome Git cheat sheet. I highly encourage you to look at it. Sometimes you get yourself in places with Git where you're like, I don't know how to get out. And this is a really good resource. And then here's some information about open source licensing in case you're interested in that. And whoops. Once again, the link to register for Hacktoberfest. So that is it. That is all I have tonight. Once again, you can find me here on Slack. You can email me. You can reach out on LinkedIn, whatever. I'm out there. But if you have any questions, let me know. And thank you.
There was one question in the Zoom while you're talking, and they asked if you could explain rebase in Git. Everyone's favorite, not merge. I can take this one if you want.
So this is the funny part is my immediate thought is don't do it. But I've recently learned that lots of people do it frequently. And it is not something that I frequent. So Sierra, if you've really got a firm understanding of rebasing.
I don't know if I have a firm understanding, but I will give it a go. I do agree with Sandi that it's very much kind of a cult thing. It's like one group's like very hardcore, like rebase, never merge, and the other is like pull it off and merge. So it's kind of interesting phenomenon.
Yes.
But, rebase, first merge are, in my opinion, almost two of the same. It just depends where your pull request starts. So when you make a new branch on Git, you're making a copy of whatever you're branching off of in that moment, and then you make changes based on that. when you're doing that on an open source project or even just like on the job, other people are contributing. And so your develop branch or whatever branch you're branching off could change. Other people could be merging in new stuff. And so what's happening behind the scenes might be different. And so when you're ready to like open your pull request or update the branch that you're working on, you have to either rebase or you can merge. And so when you use git merge and then merge that branch that you started with back into your current branch, it lays those changes on top of what you've done. So it'll be, I've made change A, change B, change C, merge, and that last change will be putting it on top. So it'll be the fourth thing. When you do git rebase, it takes all your changes off so that you're back on the branch that you started with, lays down other people's changes, and then lays your changes back on top of it. And so instead of your starting point being the develop branch right before your first change, it's the develop branch where it currently is with your changes laid on top of that. And so it's not an extra commit because it's just like rebasing where you start with new changes.
Sierra, would you say, I kind of think of it as kind of like rewriting the history too.
Yeah. Yeah.
Which
changes where you start to where it currently is versus if you like open that, made that new branch like a week ago, and so you're missing a week's worth of changes. Now it's at the current point with your changes on top of it.
Yeah. And my experience with it is like, it is very polarizing. People either want to do it all the time or they never ever want to do it. I'm kind of on the never ever want to do it side. We recently, where I work, we were working with a local firm who, that's all they do is rebase. So we brought them in to do some front end work for us, and they were rebase. They were in their own repository. That's fine. Do whatever you want. Then we had one of their developers come and work in our repository, and he accidentally rebased. Oh my God. That's all I'm going to say. It was like a flaming fire that week trying to get things back in place. So I don't want to imply that it's always bad, but I think you definitely cannot mix the two. It's one or the other. It's like, stay on your side.
So are there other questions, not least in the whole presentation? I'm taking that as a no. Feel free to break in, but I did want to call attention to a couple of things. Sandi did her whole presentation in command line, and if you don't know command line already, that can also be kind of overwhelming. GitHub has a tool, GitHub desktop, that has all your information like encapsulated in it, and then it's a GUI, so it's a UI interface to do all those things that Sandi did. And so if like now's not the right time to learn GitHub and the command line, I really recommend checking out that GitHub desktop. You can download it like right off the Git website, and if you're signed in, it will just you'll have all your repos, it'll have everything you need. You clone on the website, clone or fork on the website, you'll see it in your GitHub desktop on your computer. And so it's a really great interface for doing that without having to learn all the things at the same time, which I totally understand. I also wanted to point out that there is a free conference in October called All Things Open. If you just Google All Things Open Conference, you can find it. It's October 19th and 20th. If you like do want to go a little deeper into more than an hour-long presentation on this sort of thing, and has some really great speakers from the open source community, and I would recommend it if you are interested in that. If there are any more questions about this presentation or GitHub, I'm going to stop recording, and then we'll talk about our next meeting and take a picture, and then we can wrap up for the evening.